Quick intro. Test execution consists of two parts. 1. New feature testing. 2. Regression testing. After the code for the coming release is ready for testing, the release engineer pushes it to the test environment where testers perform a smoke test, also called a sanity test or a confidence test, to see if the main flows of the core functionalities still work. Brain positioning. Core functionality is a functionality essential to the purpose of software. The purpose of online bookstore is to sell books. So, if Charlene was a real bookstore, its core functionalities would include 1. User registration. 2. Login. 3. Search. 4. Page with book. 5. Shopping cart. 6. Checkout. If any of these functionalities stop working, users will not be able to buy books. During a smoke test, we don't do deep testing of core functionalities. Instead, we concentrate on finding blocking issues. Example: the smoke test fails if we cannot register a new user or if checkout cannot be completed. The smoke test does not fail if a user can be registered, but the email with the registration confirmation has the wrong content, or if the checkout is working but the wrong discount is given, depending on the number of books in the shopping cart. So, if you see non-blocking bugs during the smoke test, take a quick note, finish the smoke test, and log those bugs. The idea of a smoke test is to check the testability of the software, whether the software is ready to be tested or not. Depending on the complexity of the system, a smoke test usually takes 5 to 30 minutes. Often, there is no need in formal documentation for a smoke test. Testers just do a quick evaluation based on their experience with the website. If documentation is needed, for example, your manager wants it, you can do it in the form of a checklist. Naturally, if a blocking bug is found during a smoke test, the bug should be immediately escalated following logging into the BTS, so the developers and release engineers can start figuring out what's wrong right away. Once the problem is fixed, the code is pushed to the test environment again, and another round of smoke testing is performed, and so on. Once smoke tests pass, the release engineer freezes the code and the testers start the new feature testing. By the way, here is what we recommend you do right before or at the beginning of the new feature testing for a major release. Call a QA team meeting where each tester does a quick introduction to the features that he will be testing in the coming release. Quick means up to 5 minutes per person. The benefit here is that each and every tester will have a general idea about what's coming. This improves each tester's overall understanding of the system and may prevent not-a-bug situations. For example, George, who tests functionality A, finds a bug in functionality B tested by Anitha. But George doesn't know that it's not a bug anymore, but a legitimate functional change for that release. During the new feature testing, we execute our test cases, log bugs into the BTS, communicate bugs to the developers, and verify bug fixes. Now, let's talk about several things that you'll find useful in regard to new feature testing. Test estimates, entry-exit criteria, test plan, aggressive testing from Jason Fisher. Test estimates. As a rule, software companies have a release schedule. Release schedules can come in many forms, from everyone at Sharelane knows that we do a release every Thursday to complex document with a list of new features, references to specs, start, end times for each stage of SDLC, etc., for several future releases. Naturally, the QA schedule is linked to the release schedule. Let's assume that, according to the QA schedule, we have 2 weeks, 10 working days plus 4 weekend days, which can also become working days, for test preps. 2 weeks for test execution. In other words, we have 2 weeks to write test cases and do other test preps. For example, create a test automation helper, 2 weeks for new feature testing and regression testing. The problem is that even if testers stop eating, sleeping, and watching YouTube videos, there is a limit of how much testing can be done. Thus, there is an eternal conflict between the avalanche of new features that marketing and PMs want to push, and the abilities of testers to do proper testing. To find the status quo between the desired and the possible, testers submit test estimates. A test estimate includes time for test preps, time for the new feature testing. After the spec is written, the test manager asks the tester to read it and evaluate how much time it will take to write test cases and do other preps for the new feature testing, execute the new feature testing. The tester reads the spec, talks to the PM and the programmer, and based on all that info, he submits 2 figures to his manager. One figure is the estimated time for test preps, and the other figure is an estimated time for the new feature testing. The time is usually represented in hours. Example: a tester was asked to create a test estimate for spec number 8112, new search features. The tester gave the following to his manager: 50 hours for test case generation plus 20 hours to write an automation tool, 60 hours for the new feature testing. If we have 2 weeks, 80 hours for test preps, then the tester has 10 hours left, 80 minus 50 minus 20. Those 10 hours can be spent helping other testers or generating more test cases. It's also good to have some time reserved in case the estimate is not correct or in case something doesn't go as planned, for example, if the PM has to change a spec. In our case, it is more complex with test execution. There are only 20 hours left, 80 minus 60 for regression testing. Will it be enough? It depends on number of factors. For example, how many test cases do we plan to execute for regression testing? What is the overall load on the testers? Maybe some testers have a lesser load and can help their amigos. How do we write test estimates? The challenge here is the test estimates are created after the spec was simply read. But the difference between spec reading and the actual testing of the spec's feature is like the difference between reading about skydiving and actually jumping from the plane. Huge! Therefore, when you are writing your test cases or executing those test cases, hundreds of nuances come to life, nuances that you couldn't even imagine during spec reading. Below are the factors we recommend you to consider while writing test estimates. 1. What is the complexity of the feature to be tested? 2. Do you have any experience in testing similar features? 3. Is there any planned integration with the vendor's software? 1. What is the complexity of the feature to be tested? The rule is the more complex the feature, the more nuances will emerge. The more nuances that emerge, the more time needs to be spent on testing. 2. Do you have any experience in testing similar features? For example, if you are experienced with testing checkout, you'll spend much less time testing the addition of another type of credit card compared to a person who has never tested checkout. An experienced person does a lot of things automatically. He knows where to look for answers and who can help. An inexperienced person must spend time exploring things, reading documentation, which often is poorly written or outdated, bothering various people with questions, etc. The bottom line is, if you are inexperienced with some features, especially a complex one, make sure to build your learning curve into your test estimates. By the way, in the case of complex software, there are people in the QA department who become experts in particular parts of that software. This is a great thing, but there is a danger that an expert can become ill or even depart this wonderful world right in the middle of something important, for example, during test case generation. So, a QA manager must make sure that the testing of complex features is well documented and that this documentation is properly maintained. Also, it is a good idea to assign 2 testers at least to each complex area. This way we have some insurance in case of an unfortunate incident with one of them. Unless, of course, they get into the accident together. Is there any planned integration with the vendor's software? Let's say that we integrate our software with a payment processor. On high level, the test architecture looks like this. Our test environment talks to the vendor's test environment. If there is a bug or another type of problem, for example, a server is down on our side, we can solve the problem like this. Hey Billy, can you sort this out? But in the case of a problem on the vendor side, it can take hours or even days before they might fix it. Our PJM must talk to the vendor's PJM. The vendor's PJM must talk to their developers might be busy with other stuff, etc. Therefore, the gist of the problem is that our issues are not their issues. Thus, if there is a planned integration with the vendor software, you should always increase your test estimate for the new feature testing. How much should the increase be? Each situation is unique. The complexity of software and of the integration, and any previous experience with the same vendor are important factors here. By the way, after you have your final test estimate, increase it 10% just in case of any unforeseen circumstances. By the way, a very simple and often working approach is to dedicate 1 day of test preps and 1 day of new feature testing for each page of the spec. Entry and exit criteria. Entry criteria are certain conditions that allow you to start something. For example, to make a phone call, you have to have a working phone, a connection, and the phone number of the recipient. Therefore, we can say that entry criteria for a phone call includes 3 conditions. A working phone is available, a connection is available, a phone number is known. Exit criteria are certain conditions that allow you to declare that something is finished. For example, lunch at the restaurant is finished when the bill is paid, so the exit criteria for a meal at a restaurant is the bill is paid. Both test preps and test execution have their own entry and exit criteria. See the examples below. Of course, every company has its own rules, so just grasp the concept. Example, entry criteria for test preps, all specs are frozen. Exit criteria for test preps, all test preps, test cases, test tools, etc. are completed. Example, entry criteria for test execution. The code is frozen. The test cases for the new feature testing are ready to be executed. Exit criteria for test execution. New feature testing and regression testing are done. There are no open P1 and P2 bugs. By the way, the main purpose of the Go, No-Go criteria document is to specify entry criteria for a major release. Of course, the best way to keep things clean and transparent is to have entry and exit criteria for all necessary situations well defined and documented. Test plan? The test plan is the master document about the activities regarding the testing of a certain feature or another possible subject of testing, for example, how the system handles a load. Let's forget about software for a minute. Below are 2 situations. 1, you have to drive to the nearest supermarket to buy some milk. 2, you have a wedding coming soon. Does it make sense to sit and write down a plan? In the first case, no, it's absurd. Just go out and get the milk. In the second case, absolutely, because a wedding involves a large number of activities and people, and it has a significant meaning. The 2 situations above are different from a planning perspective because they provide different answers to the following questions. How quickly must the project be completed? How many people and activities are involved in the project? What is the significance of the project? Let's get back to our startup business. Consider the following. New features in startups are usually developed and tested very quickly, taking just days or weeks. There is usually 1 PM, 1 developer, and 1 tester per each feature. Any feature can be changed, removed, or deprecated overnight. So, as a rule, in the startup environment, there is no need to create a test plan. By the way, sometimes a tester is asked to write a test plan by his manager when the manager doesn't know what a test plan is. If you have a manager like this, ask him, do you want me to create a formal test plan, or do you want me to generate test cases? To be fair, there are situations when a separate test plan is needed. For example, for long-term projects or for projects that include integration with the vendor's software. Test plans come in many shapes and forms, but the majority of them have their roots in the test plan document introduced by ANSI IEEE Standard 829-1983. We recommend a simplified version of that for the most projects. Let's look at the main sections: General Info, Introduction, Schedule, Feature Documentation, Test Documentation, Things to be tested, Things not to be tested, Entry and Exit Criteria, Suspension Resumption Criteria, Other Things. General Info. Introduction. This is a short intro to the feature that is going to be tested. By the way, let's assume for the sake of simplicity that we are testing a certain feature, but you should remember that we can also test other things, site performance, for example. Schedule. Here you specify detailed info about things that should happen, when they should happen, and who is responsible. Example. Feature documentation. Here you list and provide links to all relevant documents that specify how a feature should work. Usually, those documents are specs. Example. Test documentation. Here you provide links to the test documentation needed to test this feature. Usually, these documents are test suites. Example. Things to be tested. Here you describe what you are going to test and how. Example. Things not to be tested. Here you specify which things are not going to be tested. Example. Entry and exit criteria. Here we specify the entry-exit criteria for the new feature testing of the feature. Example. Suspension resumption criteria. Suspension criteria are certain conditions upon which testing must be suspended. Resumption criteria are certain conditions upon which testing must be resumed after suspension. Example. Other things. Here you specify whatever else you want included in your test plan, for example, training, hardware, software requirements, contact info, sign-off procedure, etc. Aggressive testing from Jason Fisher. This testing technique was introduced by our friend, developer Jason Fisher. In startups, we have loads of small new features to release, and releases might happen several times a week. There can also be situations when there are many developers and only one tester. Here is what can be done in such environment. 1. After the coding is finished and the code is pushed to the test environment, the developer and the tester get together and begin discussing test scenarios. They outline major flows on a whiteboard and they decide who tests what. Correct? Both the developer and the tester will be doing testing. 2. Testing starts and the communication is done person to person or via instant messenger. All bugs are fixed by the developer as soon as they are found. New builds are pushed promptly after the bug fixes are checked into the CVS. 3. After the major flow seems to work, the developer gets back to his business and the tester spends several hours planning the testing, for example, by using the dirty list whitelist technique. Executing the testing, for example, by going through the flows on the whitelist. 4. After found bugs are fixed and verified, the tester does a quick system test followed by an acceptance test. If everything is fine, the tester gives the green light to push to production. It sounds simple, but it works fabulously. Lesson recap. 1. The new feature testing starts after the smoke test passes. 2. The purpose of a smoke test is to check the testability of the software. In other words, we are looking for bugs that block testing. 3. During the smoke test, we check the main flows of the core functionalities. Core functionality is a functionality essential to the purpose of software. 4. It's a good practice to call a QA meeting right before or at the beginning of the new feature testing for a major release, where each tester gives a short presentation about the features that he is going to test for the coming release. This improves each tester's overall understanding of the system and may prevent not a bug situations. 5. Test estimates are needed to find a balance between the avalanches of new features that marketing and the PM want to introduce and the ability of testers to perform proper testing. 6. Estimates consist of two parts: a time estimate for test preps and a time estimate for the new feature testing. 7. Things that can affect test estimates. What is the complexity of the feature to be tested? Do you have any experience in testing similar features? Is there a planned integration with the vendor's software? 8. Entry criteria are certain conditions that allow to begin something. 9. Exit criteria are certain conditions that allow something to be considered finished. 10. The test plan is a master document about the activities for testing a certain feature or another possible subject of testing, for example, site performance. 11. As a rule, startup testers don't need to create test plans. Features come and go too quickly, teams are small, and often there is not even enough time for the essential things like test case generation. 12. The core idea of aggressive testing developed by Jason Fisher is to find and fix important issues ASAP.